Okay, hi, I'm Purvok, and today we are going to discuss about graphs related to the physics. And this video is mostly important for class 9 students, those who are encountering graph for the first time in ICSE board, and maybe in the CBSE board they are having from class 6 or 7, but not so deeply. They are having a basic idea about the graphical applications in the physics while they are representing the motion in terms of graph. But in ICSE, in class 9, we have a major application of graphical represent graphs in our physics. Not only in the motion, maybe in the chapter of Newton's laws of motion, not so. You could find there is a representation of various variables in terms of graph. Now today we will understand how to represent the graph and how to use the graph in physics. So mostly our discussion will be confined within the region where we will learn that what are the important sections or representation we have for the graph, types of graph, general equations of the graph, and also in terms of physics, what are the physical quantities we can calculate from a particular relation from the graph. So let's begin with it. So initially I have divided the whole discussion about the graph related to the physics in two parts. One is the types of graph, general graph discussion, discussion on graph, general discussion on graph. And the second part is application in physics. Application in physics. Now in application of physics, mostly in each and every chapter, if we talk about in higher classes like in 11, 12, mostly in each and every chapter, whenever we have a several relations between the physical quantities, we used to represent their relations in terms of graph. And we will learn how to calculate the various physical quantities from this graph. So let's try out with this particular general discussion on graph. We will discuss few types of graph like straight line, parabola, hyperbola, ellipse, something like that. Those are most important. And we will also learn if we have any arbitrary function, then we will draw the function and we will learn how to represent it in terms of graph. Okay, so this is a major discussion part we have today. So first we will start with general discussion in graph. So first we will start with the straight line. Mostly those who are in class 11, they know the equations of a straight line, but those who are in class 9, in the beginning, they don't know the equation of a straight line. And then how can you identify by observing a simple equation whether it's representing in terms of straight line or any other curve? Basically, if you have an equation something like y is equals to mx plus c, while you are observing the power of y is also 1 and x is also 1, that means both the variables while we are plotting the graph having power 1, that will represent a straight line. It will definitely a straight line. Now depending upon the value of the m and c, the nature of the straight line will change. Okay, so m could have two possible values. One is positive, another one is your negative, and c could also have two possible values. One is positive, another one is your negative. So this c is known as y-intercept. Y-intercept, and m is known as slope. So these two are the major parameter to understand, to draw a graph. In physics, we are not looking for a coordinate based graph. We don't need a graph paper to draw the graph. We just looking for the nature. Okay, whether it have made a positive slope or not, whether it has a positive intercept with y or not, something like that. Just having an idea about the nature of the relation. We don't need to draw the coordinate based graph what we used to draw in our maths with the graph paper. So we got four possible values. So we will have a chart over here. Along with that, the nature of the graph will be along with it. So observe it, it will be easier for you to understand. So in C, the possible natures: positive, negative, positive, negative, positive, positive, negative, negative. All four combinations that I have taken. Okay, I will make little bit spacious to draw the graphs. Okay. Then negative, positive, negative, positive, negative. Okay. So when both are positive, y-intercept positive and C is also positive, the graph, this is your x-axis, this is your y-axis, graph will start somewhere here like this. This is a positive slope as well as the y-intercept is your positive. When we have a negative intercept but we have a positive slope, this graph will be little bit shifted to the negative axis of this one, like this, x, y. Now if we have a negative slope and positive intercept, the graph will look like this. And if you have a negative slope with negative intercept, the graph will be like this. So these are the four natures we can talk about. When slope is positive, C is also positive, it will look like this. We have a positive intercept in y and the slope is also positive, making an acute angle with the positive x direction. If the angle made with a straight line with a positive x-axis is an acute angle, that defines the slope is positive. As long as the angle is acute with the positive x-axis, the slope remains positive. If we have a obtuse angle which is made with the positive x-axis, here we can see in the third and the fourth case, the obtuse angle they have made with the positive x direction, that confirms the slope will be negative. And the intercept, definitely this is the positive x-axis, this is the positive y-axis, negative y-axis, positive intercept means straight line will pass through somewhere in the positive coordinate of the y, negative coordinate is somewhere in lower part, again positive part, lower part. So this could be the possible nature we have for the straight line. Many other forms of the straight line we also have, like the slope intercept form. This is your slope intercept form. Now we have an intercept form, that is x by a plus y by b is equals to 1. Coordinate based form, x minus x1 by x1 minus x2 is equals to y minus y1 by y1 minus y2. All of these are the different forms of the straight line equation, but most important and what we most use in our physics, that is y is equals to mx plus c. So these are the four natures of the straight line. Here we can conclude our discussion for the straight line. What are the other forms we have? But the most important, that one of the variable is remain positive and another variable is become quadratic. Okay, remains to the power 1. One of the variable have to the power 1, another one have a power 2. So that could be a quadratic equation, single variable quadratic equation. We will see what nature of the graph we will observe if we have this kind of equation. Here we could have one equation that y is equals to y squared equals to 4ax, or y squared is equals to minus 4ax. One we have a plus 4ax, another one has minus 4ax. Let's see how does it looks like. If we have if you could say this y is equals to root under 4ax, that means for a single value of y, that we could have two values of x. So for minus y we have a value of x, another one is plus y, we have another value of the x. So this will looks like this. Two values of the y will produce a single x. Plus y will give you the same equation, minus y will give you the same equation, because once we square it up, minus will vanish. So this plus minus y will give you the single value of the x. So that's why this graph will looks like this. Whenever we have a negative minus 4x, the graph looks like this. and this is the nature. You can say this is a vertex point. This is a vertex point. Simple. So now we could have another one, that is your x square is equals to 4ay. X square equals to 4ay. X square is equals to 4ay, and x square is equals to minus 4ay. So if we have that, so the graph will look like this. This one will be looks like this. So upside and downside. These are the two possible graphs we could have. This is known as parabola. This graph is known as parabola. These are the two important algebraic relation between x and y, what we have an application, major application in physics. Other than it, we have the logarithmic graphs, we have trigonometric graphs, we have exponential graphs. Although those are there, but in respect to class 9, we can restrict our discussion over here only for graphs, general discussion on graph. One we have done for the straight line, where you have seen we are considering the equation y is equals to mx plus c, where m is considered as the slope of the straight line and c is the y-intercept. So as a combination of the positive negative natures, we have drawn the 4 possible graphs. So whenever you will given with the equation, you need to rearrange the equation in that way, y is equals to mx plus c, and then afterwards you can draw the graph. So let's give an example regarding that, so that you can sort out whenever you will have a problem, you can solve that problem. For any kind of equation, straight line equation, suppose 3x minus y is equals to 6. So our representation is y is equals to, our equation is y is equals to mx plus c. So whatever be the situation, we need to rearrange this equation in terms of y is equals to mx plus c. Something, the coefficient of y is 1, coefficient of m, coefficient of x is your m, that is the slope, and the constant part will be the y-intercept. So here we can take the y on the right hand side and c on the left hand side. So it will be y is equals to 3x minus 6. 3x minus 6. So coefficient of x is positive and the y-intercept is your negative. So the graph is your positive, negative. The graph will be like this. We are not bothering about the points where they are intersecting. We are not writing even the coordinates. We are only looking for the nature. So another example we can take. Simple examples. 2x plus 5y is equals to 7. So we need to rearrange them in terms of y is equals to mx plus c. So let's take this 5y on the left, 7 in the left side. So 5y is equals to 7 minus 2x. So instead of taking this, I am taking 2x on the right hand side of the equation. 5y is equals to 7 minus 2x. So y is equals to minus 2 by 5x plus 7 by 5. Minus 2 by 5x plus 7 by 5. So from this particular equation, we could identify the slope is your negative and the y-intercept is your positive. So the corresponding graph for this one, x, y, this will be this. Obtuse angle means the slope is your negative and the intercept is positive, is over here. So these are the simple equations that you can draw from the graph. From the equations, once you observe the equation, then you can draw the graph. Now in physics, mostly we don't have a straight line equation every time, or mostly we are not given with the equations every time to draw the graph. Sometimes a problem is given with a statement and you need to understand that. So we will discuss that part in a few minutes later in the next video. Okay, so thank you for watching. Thank you.